we're going to go through a few pointers on actual stud welding that hopefully will be useful in improving the welding results in your shop. This is a piece of cold rolled steel. Don't have as much contamination from that as you do on the hot rolled. Again, the weld procedure, stud and the ferrule are loaded in the gun. The plunge travel is taken up. You feel for perpendicularity. Frequently, it's easier to sense perpendicularity with the second hand rather than through the handle of the gun. And just use the handle and your hand on the handle for triggering the gun. The weld berries are an indication that you've got a good hot weld. We'll take that out. The weld berries and ferrule break off easier after it's cooled slightly. You have a glazing in there between the fillet metal and the ceramic ferrule. If you tried to break that off immediately, the ferrule wouldn't have chilled, but we've got a nice bright fillet appearance there. In making the same weld onto mill scale, you'll get more metal expelled in the form of weld berries and slag. Take up the plunge, centering, trigger. Let it cool a second. The weld, in this case, there are a few more berries adhering from the slag situation. Another thing on this, I was just loose on the bench. Close examination on this, you can tell little arcing marks where the ground contact was made. In this, on the cold rolled, I've got a stud on the back side, but it has less arcing, or more, they're distinct in the hot rolled where the ground occurred. The ground location, if it had occurred all on one side, could have forced the fillet metal away from it. That's important in grounding on a large part. Frequently the grounding is the further you are from the ground contact point, the less violent the effect of the ground is. Sometimes on long bar-shaped pieces, two grounds are useful, one at each end to balance the current flow. Ground connection is, say, as important as a connection, the circuit between the stud and the chuck, the whole circuit through the accessories, including the ground contact point on the part, is essential to the weld quality. The ground contact must be tight and clean to keep from having a metal loss or an arcing in the ground location. You can destroy the, say, a C-clamp like this is useful in that the end of the clamp binds and bites through the mill scale on the material. Clean material is easier to deal with, but on mill scale you need something that'll bite through. You can't just have a spring-loaded clip. You could have a set of vice grips, say, with a bolt stud connection on it, but in those you should, again, scour through to where you've got a good tight connection for your ground circuit. In this case, we've got a ground to the center of the weld bench with a cable coming up. Knowing where the ground location is attached is important too. The cable, you'll watch a cable during a weld and it will move. The current going through there has a magnetic field build up around it and collapse during the weld cycle. You can use that force to work for you, or it can work against you in welding certain parts. The position of the ground, the basic rules are that weld fillet metal will go away from a cable or away from a ground contact point. In welding on a vertical surface, you've got a problem due to the effect of gravity pulling the fillet metal down, and you have difficulty in filling the weld at the top of the piece here. You can get a good fillet at the bottom, but getting the fillet at the top is difficult to accomplish. One thing, well, there are several things that can be done to improve the weld results on a vertical face. We make special ferrules for the larger diameters that have the serrations or vents blocked off at the bottom to prevent metal from dropping out of the bottom. If you don't have the ferrules with the block vents, frequently you can shift the gun, the centering of the foot, so that the stud rests in the bottom of the ferrule, and we recenter this, all of the cavity and all the clearance is at the top of the ceramic ferrule. We've got the stud laying in the bottom of the cavity. There's as little space down there as possible, and the chances of filling at the top are improved. Another thing is to, if possible, make sure the ground connection is below the weld location. If we're welding to a vertical face and have the ground clamped here, you would be adding to the gravity effect from the ground effect. Another thing, using the cable in welding to a vertical face, if the cable is positioned below the weld, you get the field going through the cable that is going to help bring fillet metal to the top. That same cable effect is useful in parts that are welded on a bench. If you're near the edge of a part and consistently the metal is going one direction in one location near the edge of that part, you can hold a cable on the side where the fillet metal is heavy, and force metal back and balance, get a uniform fillet around the base of the studs. Center punching on a part can make a difference. It might be slight, but the depth of the center punch mark can change the lift. If you're set up to weld to center punch marks, and they're fairly deep center punch marks, all that welding should be done with one lift adjustment, and then the lift may have to be shortened if you were going to weld to a part without the center punch mark. You can reduce the amount of cleanup necessary on a mill scale part by grinding the mill scale off either with a solid disc or a wire wheel or abrasive wheel. That reduces the amount of slag and weld splatter you're going to have expelled from the weld. Now, the other thing that, rather than surface condition, you've got mill scale, you've got rust, oil, paint, platings that can jeopardize the weld quality. At times you can overcome that, either the cleaning operation, or frequently we'll run longer weld time and try to just expel and burn out the contaminant. Preferably you can get rid of it, and your weld fillet will look a lot better.